Rob-See-Co Future Farm. Today's innovations, tomorrow's solutions.
Hello and welcome back to the Rob-See-Co Future Farm. I'm here with Aaron Wulf, our Quality and Production Manager. Welcome, Aaron.
Thank you. Glad to be here.
So, Aaron, we are in front of corn. It's not a typical production field, not a typical commercial corn field. What are we standing in front of?
We're standing in front of one of our seed fields. It's been detasseled and pollinated at this point. So, yeah, that's where we're at.
I have to ask before we get into things, what is the hybrid that we're making in this field?
We're making RC 5430 Drought Guard Double Pro.
So that's a big hybrid in the portfolio. It's a hybrid we love. The production field looks good, but first of all, tell us about seed production. Yeah, what are we doing here?
Well, what we're doing is we're trying to cross two unique sets of genetics to make a hybrid. Make something that's robust, carries all the agronomic attributes we want, and most importantly, develop a quality product.
Exactly. I mean, without a quality product, that just results in poor yields for the farmer and just a really bad overall experience. And so there's a lot of things that go into quality, Aaron, and I've always learned quality starts in the field or is made in the field. So walk me through how that works.
Sure. I would probably back up just a little bit. Quality actually develops coming from the breeder, parent seed group that develops and increases the inbreds, but from a production standpoint in planting. One of the key components when selecting a field is what's around the field. Is it soybeans? Is it commercial corn? Is it other seed corn? Those are items that we want to identify well up front in the planning process when we're selecting the field.
We take a look around us right now. We're obviously, the seed production here is behind us. The headlands of this field was corn, but it's all mowed down right now. And actually across the road on any direction, it's soybeans. So why that space, and why are these, why the way it is?
The male rows are just extra protection for the and for the machines to turn around in this particular field. Ideally, you wouldn't technically need the male rows because across the road is soybeans. But if it was corn, we would need 165 feet of isolation coupled with the 16 rows of male, just to help protect ourselves in case that commercial field would pollinate at the same time as our seed field.
Yeah, we don't want foreign pollen blowing into our seed field and creating outcrosses. So plants that would have the female genetics, so the plant that makes the ear, that makes the seed that we plant, but if there's a foreign pollen blowing in, that's not going to make the hybrid we want, right?
That's correct. It would make something that we would not want in the field. We would not want to sell to our customers because once again, we wouldn't be delivering on the promise of the hybrid, pure genetics, traits, and physiological quality.
Yeah, there's genetic and trait purity. We've got to have as high of a percentage of pure hybrid seed for the intended hybrid we're after in the bag as possible. And you mentioned that there's spatial isolation that we can get. And then you also mentioned pollinating at the same time. So what is this about the timing aspect of pollination that improves or impacts quality?
Yeah, great question. The pollination is key when it comes to quality. But that starts at planting time. And well, once again, it starts with the breeders and the parent seed group and those that characterize the inbreds. We look at our heat units to silk on the female and our heat units to pollen on the male. And now the key and the art is combining that, and the only way to do that is during planting time.
Yeah, so at planting time, you might have a female inbred that silks a lot earlier or later than the male inbred that's going to be used to donate the pollen. So how at planting time and planning time, how do you address that?
Yeah, so we will have multiple plantings in a field. If the female takes longer to silk, it gets planted first. And then the male gets planted after that. And we do 2 male plantings. The reason for that is to spread the pollen over that silking window.
Yeah.
So figure a silking window of 4 to 5 days. We want that male pollen to be out there probably 6 to 7 days, just to cover any silk that might be exposed.
Yeah, and so, I mean, as we look at this field that's behind us, we have 1, 2, 3, 4 female rows for every male row. But if you look at the male rows, it's a little bit goofy. It's almost like a split planter. Is that how they do the multiple plantings in the single row?
Yes. Yeah, they'll have unique planters that come out, and they'll have just those male row configurations on it, and that's how they'll plant those male rows at a second planting.
I've driven down the highway a lot, and I've seen seed production fields where it may not be 4 female rows and 1 male row, 4 female rows, 1 male rows. Are there other configurations, and why those configurations, and how does that impact quality?
There are multiple row ratios, is what we would call in seed production, and it all is classified based off the male. How well can the male extrude pollen and pollinate the female? If it's a poor pollinator, yeah, we're going to be probably 4 female to 1 male, and then a 4-1, 2-1, with 4 female, then 2 female for every 1 male row gap between. If it's a great pollinator, we're going to go 6-1, 4-1, where we have 6 female rows, 1 male, 4 female rows, and then another male.
Yeah, that works out really well because you can get more seed per acre doing that. Yeah. So what else do we need to know about seed production in the field and how that results in quality?
Well, the other piece is detasseling. It is the next critical component once you get your timing in place. And we need to make sure that we're not having the female expose its pollen and pollinating its own ear.
Right.
We want exclusively that male pollen to pollinate the female.
Yeah.
So we have to detassel.
Yeah, and there's more than one way to detassel, right? I mean, or block that pollen from reaching the female pollen from reaching the female ears, right?
Yes. Yeah. The traditional method is to do a machine cut with a mower blade over the top of each row and take about 1/3, maybe a half of the tassel, and then let it sit for 2 days for that tassel to grow, followed by a wheel puller, what we call a wheel puller, which has 2 wagon wheels, 2 sets of wagon wheels per row, and they're designed to pinch together and spin together to create a pulling mechanism to pull the tassel up and out. That gets about 80 to 95% of the tassels, depending on the field. After that, we'll send in crews to hand pull the remaining amount to get out of the field.
Excellent. That's where you see teenagers all across the Midwest having their first job as detasselers, and it's really key to get all those remaining tassels out so that we can make only hybrid seed, not inbred seed in the bag.
Correct. Yeah. We don't want those inbreds or what we call selfs inside that bag, because it will degrade the performance for our customers out in the commercial field.
Aaron, there are still these male rows behind us after this pollination has occurred, and so to avoid harvesting ears from those male rows, what happens to them?
Well, we destroy them. They've served their purpose, and we'll remove them from the field. It could be a couple of different methods. One, a rolling stock chopper, just kind of rolls over the top of them and cuts them down. Or you can use a blade chopper that will go in and kind of shred them like a silage chopper.
Okay.
But yeah, we want those removed, because at this point, that plant served its purpose, and its purpose was pollen.
Yeah, it's specialized equipment to serve that end.
Yeah.
As we progress through the season, a lot goes into harvest timing, harvest moisture. Tell us how that impacts what goes in the bag.
Well, that's where the physiological quality really kicks in. Obviously, there's some genetic components there. Each female has its own inherent qualities, but now it's how we manage what we inherently have currently in that female. So moisture content at the time of harvest is critical.
What is that typical moisture range?
Typically start at 38, but then it may get lower depending on the female.
Yep. So it's really high moisture compared to commercial corn.
Correct. Yes.
Yeah. And why harvest at such a high moisture?
Our goal is to get everything out before a frost hits. Any freeze event when the seed corn is still in the field can jeopardize our germ and cold scores.
Exactly. And so, I don't typically see your normal combine out harvesting seed corn. It's something a little bit different than you're used to seeing. It almost looks like they're harvesting the whole ear. Yeah,
it's going back to the ear harvest methodology and putting it into a bin to dry down to a certain extent. But yeah, everything's harvested on the ear, typically with husks. Obviously, certain genetics pick clean and some do not.
Yep.
And so everything's harvested on the ear so we can control that moisture and can control the quality and avoid the damage to the ear of corn.
Exactly. If you shell corn at 38% moisture, you're going to have a lot more damage to those kernels than if you shell corn at 15, 14% moisture.
Yeah, your equipment might be a little messy at that point.
You know, now we've made our way through pollination, we've talked about harvests and how all these things work. You know, I think maybe later this fall we should revisit and see what happens after harvest, after we've husked, shelled, dried, husked and shelled the corn, and see what happens to get it in the bag. So we'll revisit at that time.
That sounds great.
All right, thank you, Aaron.
Thank you.